So moving on, right, question 5. Miriam and Adam agree to relieve the boredom of the school holidays by eating sweets, but their mother insists that they limit their consumption by obeying the following rules. Miriam eats as many sweets as on any day as there have been sunny days during the holidays so far, including the day in question. Adam eats sweets only on rainy days. If day K of the holiday is rainy, then he eats K sweets on that day. For example, if the holiday is 8 days long, okay, then this happens. Okay, and we can see those rules are obeyed there. Okay, right. So if the holiday is 30 days long, 15 of which are sunny and 15 are rainy, what arrangement of sunny and rainy days would lead Miriam to eat the greatest number of sweets in total, and what arrangement would lead to the least number? Give the number of sweets that Miriam eats in each case. Right, so if she eats, so if she eats the number of sunny days that have happened so far, including the day on which it is sunny, then you want to move all of your rainy days to the end so that she continues to eat on those days. Okay, so I'll just do it for say 4 days or something. If it was rainy here and then sunny here, you'd go 1, 2, 2, 2. Yeah. So in the case of moving all the sunny days to the front, we go 1, 2, all the way up to 15, and then for the next 15 days, she just goes 15, 15, 15, etc. Okay, so we have 15 times 15 here, which I think is 225, and we have the sum of 1 to 15 here. So 1 to 15, I think there's a formula for this. It's like the triangular numbers. I think it's this. Is it m plus 1? Something like that. You can use the formula I quoted earlier for an arithmetic sequence with a equals 1 and d equals 1, 2. So actually, yeah, I've made a small mistake there. So this is the formula, plus d n minus 1. Okay, if you had to, you could derive this, I suppose, but best to know it. So a is 1 in this case, so I'd say it's 15 over 2 times 2 plus 1 times n minus 1, and n is 15, so that's going to be 14 there. So it's going to be, 15 times 16 divided by 2, so that's 8 times 15, so that's 4 times 30, which is 120. Okay, so the answer is 120 plus 225, which is 345. Okay, so that's the maximum she eats. She eats a maximum of 345 sweets, okay, 345 sweets, and that happens when you move all of the sunny days to the front. Okay, so the greatest number of sweets, and what arrangement would lead to the least number? Give the number in each case. So I guess the least number is the opposite, right? You just move all of the sunny days to the back. You move the rainy days to the front. So it's like 15 zeros in a row, and then 1 to 15. And we know what 1 to 15 is. It's just 120. So the smallest number is 120 sweets. The largest number is 345. This happens with all of the sunny days at the front. So I guess I could write it as sunny to the power of 15 times rainy to the power of 15, if that's the notation I'm going to use. And here I would use rainy to the 15, sunny to then the 15. Okay, all right, that's fine. So that's part I done. Show that in the 2 cases mentioned in part I, Adam eats the same number of sweets as Miriam. Okay, so if the sunny days come first, then how many sweets does Adam eat on those sunny days? He eats none, right? But, okay, here's what happens. So on day number 16, Adam eats 16 sweets, okay, all the way up to 30. So you could use this formula again, or you could actually note that if you take out 15 times 15, so each of these is made up of 15 plus 1, 15 plus 2, 15 plus 3, 15 plus 4, up to 15 plus 15. So I've got 15 times 15 plus 1 plus 2 plus 3 dot 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 up to plus 15. Okay, so 15 times 15 is still 225, and 1 plus 1 plus 2 plus 3 all the way up to 15 is still 120. So that still equals 3, 4, 5. Okay, and what about in the other case? Well, in the other case, the rainy days come first, so he just eats 1 sweet on day 1, 2 sweets on day 2, all the way up to 15 sweets on day 15, and then zeros from then on. Okay, then loads of zeros, right? 15 zeros followed by that. So this is again that sum which just sums to 120. So there you are, you've shown it for Adam. Okay. So suppose in any sequence of sunny and rainy days, we arrange to swap a rainy day with a sunny day that immediately follows it. How does the total number of sweets eaten by Miriam change when we make the swap? What about the total number of sweets eaten by Adam? Okay, interesting. So let's say that we have like rainy, sunny, rainy, sunny, some sort of combination, and then on the nth day and the nth plus 1 day, we have, what was it? We arranged to swap we arrange to swap a rainy day with a sunny day that immediately follows it. So this is a rainy day, this is a sunny day, okay? And then I guess we've got, some sequence of rainy and sunny going on here. Okay, so these are some combination, and these are some other combination here. And we're just going to arrange to swap these two. So if we arrange this swap for Miriam, we actually put the sunny day a little bit earlier and the rainy day a little bit later. Okay, so here, let's say that there were let's say that there were alpha sunny days so far. Okay, so in the original arrangement, she would get alpha on the rainy day and alpha plus 1 on the sunny day, which sums to 2 alpha plus 1. Okay, and then it doesn't really matter what order these two are in for the next combination of days. Okay, because it will still have an extra sunny day in there for those consecutive days afterwards. So what happens if we swap them around? If we swap them around, we get alpha plus 1 on the sunny day, and then on the rainy day we get alpha plus 1 as well. So we would end up with 2 alpha plus 2. So we add a extra sweet to Miriam's diet, I guess, over this holiday. And for Adam, what's going to happen? So Adam only eats on the rainy days, and it's the number of that rainy day. So for Adam, he would eat n sweets in the first case. When R is in the first position, he would eat n sweets, and then on S he would eat nothing. But if we swap them around and make the sunny day earlier and then the rainy day a little bit later, he would eat n plus 1 sweets. So Adam also adds 1 to the number of sweets that he eats, just by moving that rainy day 1 later. So both of them just add 1, okay, from any swap like that, and that's the answer, I think. Okay, how does the total number of sweets eaten by Miriam change? What about the total number by Adam? Okay, so both add 1. If the holiday has 15 sunny days and 15 rainy days, must Miriam and Adam eat the same number of sweets in total? Explain your answer. So I think the answer is yes, because we know that they both start off with the same number. If you say so what swap have we got here? We know that if we swap sunny and rainy if we swap rainy and sunny to sunny and rainy, we add 1 to both of their numbers, so they both stay the same. Okay, and we've also proved that for the case of rainy, 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 or rainy, rainy 15, and then sunny 15, they both eat the same number, which I think was 120. So both Adam and Miriam eat 120 sweets in this case. But then what we could do is we could make consecutive swaps of sunny and rainy, right? We can just keep swapping in sunny and rainy. And I think it's true that we can create any combination of rainy and sunny just with a sequence of consecutive swaps. So if you think about it, if you want, say, sunny in the third position, okay, in third position and at sixth position and all of these positions, you would just swap them in so many times. Okay, so even if you want sunny in the first position, you would just have to make, 15 consecutive swaps to move that sunny to the first position. And then you would end up with the case of sunny and then rainy to the 15 and then sunny to the 14. And then you could move, I don't know, say you wanted sunny in the third position, then you would make another consecutive, how many swaps would that be? That would be, so you want it to be rainy there, so it would be 14 swaps, right? Rainy, sunny. If you kept doing those swaps, you'd just keep adding 1 to Miriam and Adam's scores, and because every time you do that, it adds 1 to both of their scores, they will remain the same number of sweets for each of them. So it doesn't matter what combination of sunny and rainy comes up, you're still going to have Adam eat the same number of sweets as Miriam. Okay, and I think that's a good argument for what follows here. So I suppose you have to say that you start with the same number because we proved that in part I and II. Okay, and then you have to say that because we proved in part 3 III that that these swaps don't change the number eaten. Well, they increase both of their numbers eaten by 1. Then it's not going to change the overall amount that they both eat. Okay, does that make sense? Or it is going to change the overall amount that they both eat, but they both will eat the same amount no matter what happens. Okay, because you can get to any arrangement by a series of consecutive swaps. It's basically like saying you can put a sunny at any position you like in those 30 slots that you have just by a series of swaps. Okay.